I have the privilege of calling your attention today to what is probably one of the most far-reaching generalizations of the human mind. And while we're admiring the human mind, we should take some time off to stand in awe of nature, which can follow with such completeness and generality such an elegantly simple principle as the law of gravitation. And what is this law of gravitation? It is that every object in the universe attracts every other with a force proportional to the mass of each and varying inversely as the square of the distance between them. If you like mathematics, you can write that same thing as an equation, proportional to the mass of each and inversely as the square of the distance between them times some constant. Now, if I add to this the fact that an object responds to a force by accelerating. Well, while Kepler was discovering these laws a little bit later, Galileo was studying the motion of matter. You see, the problem is, even if you know this, what makes them go around? And in those days, one of the possible theories that were proposed was that what made the planets go around was that they were behind them here located invisible angels which are beating their wings and driving the thing forward. As you'll see that this theory is now modified. It turns out that in order to keep them going around, you need the invisible angels to be flying in this direction and to have no wings. Otherwise, it's a somewhat similar theory. Now, Galileo discovered a very remarkable fact about motion, which was essential in order to understand the reason for these laws. And that is the principle of inertia, which is this, that if you have something moving and just going along and nothing touching it, just not disturbed in any way whatever, Galileo realized by some experiments and generalizations and idealizations that he proposed that it would go on forever, coasting at a uniform speed in a straight line. In other words, if nothing disturbs an object, it'll keep on coasting at a uniform velocity in a straight line. Why does it keep on coasting? Maybe it's the angels, but we don't know. But at any rate, that's the way it is. Then Newton modified this idea and said even more, that if you want to change the motion, you do it by a force. If you want to speed it up, or it gets speeded up, when a force is applied in a direction of motion. It gets its speed changed into a new direction if a force is applied sideways, and it's deviated sideways. So Newton added the idea that you need...